Now that we know what triggers an electric current, the source is an electric cell. A source, that is the electric cell, is required to produce a uniform flow of charges in a circuit. The main function of various electric cells is to maintain a constant potential difference between its two terminals that we have seen, which triggers the electric current to travel. So children, let us learn about the electric cells that are currently in use. Let's understand the working and the construction of different parts of an electric cell, that is mainly the dry cell. A dry cell is generally used for the home and portable electrical devices. These devices that we can see are of various sizes and shapes. What do? They convert the chemical energy stored in them into electrical energy. And this electrical energy is used to convert into or transfer into sound energy, heat energy, light energy, and so on, depending upon the appliances that we use. So, nowadays, most commonly used batteries are the dry cell batteries, which vary from large flashlight batteries to minimized flashlight batteries and also are mostly used in wrist watches and calculators. So let's understand what is the working and construction of a dry cell, the inner components of a dry cell. So to understand the construction, let's take a dry cell and remove its outer coating and observe the cross-sectional segment. To begin with, a battery contains electrochemical cells that can store chemical energy in an immobilized electrolyte paste to be converted to electrical energy. So let's understand what a dry cell is. A common dry cell is the zinc carbon cell. A standard dry cell comprises of a zinc anode, usually in the form of a cylindrical pot, and a carbon cathode in the form of a central rod. The purpose of the carbon rod, which is at the center, is simply to allow the flow of electrons. The top of the cell contains a layer of sawdust. This acts as the base for the top layer of bitumen used for sealing purposes of the cell. The carbon rod is surrounded by a mixture of manganese dioxide and charcoal, reducing the internal resistance of the cell in a muslin bag, which acts as a depolarizer, preventing building up of hydrogen gas bubbles and accepts electrons during the discharge of the cell. The carbon powder increases the electrical conductivity of manganese dioxide and retains the moisture of this electrolyte. Manganese dioxide present in this dry cell improves the performance of the cell by absorbing the hydrogen gas which is produced after the chemical reaction that takes place, and acts as a depolarizer and keeps the solution moist and increases the ionic mobility, reducing the internal resistance of the cell. Around the carbon rod is a chemical paste of ammonium chloride and zinc chloride. So it is surrounding the carbon rod. It keeps the paste wet, containing the negatively charged particles and the positively charged particles, also called as ions, which are actually the carriers of electricity. The zinc sleeve, that is contained as a container made up of zinc material, which is a metal. It is a conductor. The electrolytic paste is covered in this zinc metal or zinc sleeve. These electrons will flow through the electrolyte into the carbon rod to produce an electric current. The sleeve will then get thinner and thinner as the zinc oxidizes, and the battery will no longer be able to conduct the electricity once the zinc sleeve is completely gone. A vent is provided in this layer to allow the gases formed in the chemical reaction to escape. A brass pin in the center of the cell conducts electricity to the outer circuit. So this was the construction of the dry cell. Let's understand now, how do dry cell batteries work when they are connected to the outer components. The dry cell, as we know, create electrical energy by converting the chemical energy which takes place due to the chemical reactions of the electrolyte with the electrodes, that is zinc and carbon, and converts this chemical energy into electricity. These materials are placed within the electrolyte paste, that are zinc and carbon within the cell or the battery. They react with each other through a chemical process in which the electrolyte carbon or manganese dioxide reacts with zinc, creating electricity. Thus, because of the chemical reactions of all these chemicals, the electrical charge is produced on the two terminals, the graphite rod and the zinc layer at the base, and an electric current flows in the circuit. This is transmitted out of the battery from the positive end, that is, which is at a higher potential, to a terminal at a lower potential, that is the negative terminal. A chemical change in the cell makes it become negatively charged. At the same time, the carbon rod becomes positively charged. When this happens, electric current flows out of the cell when a conductor, that is a wire made up of a metal which is a conductor, is attached between the cells. From the positive terminal towards the negative terminal. The negative charges, that is the electrons, always travel from the negative terminal towards the positive terminal of the cell, unlike the electric current. Now, we have understood that the basic power unit inside a battery is called a cell. It contains, once again, we know, two electrodes along with the electrolyte in between them. For our convenience and safety, these things are usually packed inside the plastic container or outside case of the cell. There are two terminals which are formed, one the positive and the other which is the negative. The electrodes are placed inside. When you connect a cell with a conductor, The electrolyte starts buzzing with activity. Slowly, the chemicals inside are converted into substances, that is, positively charged ions or particles and negatively charged ions or particles from the materials inside in the electrodes, and they take part in the chemical reaction with the electrolyte. At the same time, electrons move from the negative terminal towards the positive terminal of the cell through the circuit, powering whatever the battery is connected to. Now the question arises, why two electrodes of different materials which obviously are connected or have to be used? The answer is that we use electrodes of two different materials because they are conductors of electricity. And we know chemical elements differ in their ability to pull electrons towards them or give up to the other elements. So we call this as electronegativity. So two different materials into an electrolyte are connected through an outer circuit so that one becomes a negatively charged terminal and the other becomes a positively charged terminal, triggering the electric current to flow through the circuit. If both the electrodes in the cell were made of the same material, would there be a flow of electrons? Would there be a flow of electric current? No, definitely not. No power would ever be produced. Hang on, children. This doesn't make sense. Why do electrons do not take a shortcut from the negative terminal towards the positive terminal? Because unlike charges attract each other, then why don't they take a shortcut? Why do they travel along this electric circuit to come towards the positive terminal? This is because the electrolyte which is present inside acts as an insulator, a barrier that cannot allow the negatively charged particles to cross them. The easiest path to move towards the positive terminal then is actually by flowing through the outer circuit. So thus, this was how the dry cell works and triggers electric current. Now, let's understand the advantages and disadvantages of a dry cell. The advantages of dry cell, as you can see, are the compact size, which makes them suitable for powering small electronic devices. The electrolyte used in the dry cell is relatively not so harmful to the environment. Dry cells are very less expensive as compared to the electrical cells. Using liquids, the life of a dry cell is longer. The disadvantages, if we look into, the main disadvantage of a dry cell is that it cannot be recharged once it loses its electrical power.